This tutorial will cover interface in details. We actually cover with tutorial number 59 when we discuss about class relationships. So one of the idea is we can use interface to model. Is a extension of relationship, happen to be a weak relationship. Strong relationship, of course, we can use inheritance. Main idea where I use interface is to define specific behavior or common behavior for classes. So that when we construct the multiple objects based on the same class type, we can control what we can manage. Same behavior. For example, multiple objects are editable if they are all defined on the certain interface called editable, or some objects can be comparable with the same object type. For example, if we have multiple triangle objects, we can say the small, medium, large triangle objects, and so on. Most popular interface is comparable and clonable objects. Clonable interface. So this is the main reason. It represents weak is a extension of a relationship. Also to define common behavior of classes. Let me draw a conceptual UML class diagram. Means I'm going to use a name of class at the moment without mentioning constructor or data field or methods. Just try to describe the relationship. So we have an animal class and then multiple subclasses of animal superclass. We have a cat too, and a wild animal called tiger. And we are going to have another class called fruit. Straightforward, apple and orange. So if we focus on hierarchy, we have a superclass called animal. We have multiple subclasses: cat, chicken, dog, and duck, and tiger. And then apple and orange. So if you look at the common behavior of subclasses, all these 5 animals make a sound. And then those 2 fruits, both of them are piece of fruit. strong relationship. Let's focus on animal. Let's change animal to be abstract class, and then with one abstract method, sounds method. So we have abstract class, abstract methods. Both of them are written in italic. Also happen to be superclass. So that is abstract class. And then abstract methods. Again, it should be in italic for UML class diagram convention. Next, I'm going to make some space so that I can continue through interface. So when we have either interface or let's say class food, you assume that all animals are eatable. Of course, we will have a question mark for that, or we can say animals are food. So both of them can be troublesome. But we can say that fruits can extend food. That's a reasonably good relationship. So when you think about it, especially the chicken and then dog is usually eatable, so that it can be implemented using interface. So let me draw a dashed line. Dashed line actually means we are referring to interface. Chicken implement eatable interface. So fruit implement eatable interface. And then chicken implement eatable interface as well. And then dogs implement eatable interface. It's a weak relationship. That's why we are using a dashed line. But at the end of the line is a triangle, similar to inheritance. There are two subclasses we can identify more clearly. Here I'm going to have abstract methods. How to eat. It means any classes implement eatable interface must implement how to eat abstract methods. Here, let me make some minor change. We can actually say that we have a pet. That means there is a subclass of an animal. And then we can have two subclasses of a pet, happen to be cat and dog. So pet is abstract class. I made some minor change. Okay. So chicken is subclass of animal, also implement eatable interface. I swap between chicken and cat. So cat and dogs are subclasses of pet. Okay. To make it more visible. Okay. Okay, let's look at the demonstration. So let me create a superclass called animal. This is going to be a abstract class with one abstract method called sound. So basically just describe the sounds of animal. Next one, I'm going to have a subclass of animal. So say extend animal. So we need to implement sounds of animal. Here I'm not going to implement because pet we cannot guess. It can be any kind of animals can be a pet. So we cannot say which sounds we can describe. It can be a cat, it can be a dog, it can be anything. So we just say abstract. Now we have something more specific like a cat. This animal has a common behavior called making sounds. I would say meow. Let's make another one. Again, extend pet. I will just say park. So we have two subclasses of pet. We will have a chicken. Normally we don't say as a pet, we just say animal. So implement abstract method called sounds. Again, two more animal to go. Stand animal. Again, we have to implement abstract method called sounds. Let's have one more animal called tiger. If you look at the navigator window, show you subclass and superclass relationship. So we will continue with fruits. We'll have two subclasses of fruit. And then we are going to have one interface called eatable. Eatable interface, again, interface can have only constants and abstract methods. So let me add one abstract method called how to eat. So any class implement eatable interface, we must implement how to eat abstract method. Constants, I'm not going to add anything. So here implement eatable. So here we say that implement all abstract methods. So how to eat. Actually, that can be very tricky because it can be anything. So we change to abstract. Also, this one we change to abstract. This region we will make it how to cook. No, I mean how to eat. Depends on types of fruits. So for example, Apple extend 1s, extend fruit, implements E-double interface because we cannot have a two superclass. So we made it through as a superclass and then weaker relationship, call it as E-double. We implement as a interface, okay? So Apple here, we will say make apple cider. Again, orange is a subclass of fruits. Also, we can implement E-double. Again, we got to implement abstract method belongs to E-double interface called how to eat. So the reason I changed to abstract because not every fruit is eatable, or some fruits cannot be eatable. So you can just change to concrete class, okay? Don't have to be abstract class, concrete class, okay? And no implementation, nothing in it. Okay, and now we can build the application. We are going to deal with multiple objects, maybe two different types of objects. One is animal, one is fruit. So array list, the question here type, class type can be animal. Then that will be same as an animal. Of course, we can omit. The question is, can it be animal and fruits at the same time? We can't do that unless we use a superclass of animal and fruits. So we can use object class. Object class can refer to any subclasses because object is a superclass of any classes. So the polymorphism works here. Now apple is comparable because apple is a subclass of object. So let me construct the objects according to number of class we have. Next one is chicken. That should be G. We are going to have orange. And then tiger. I'm going to just copy paste it for 6 times, I think. Apple, cat, chicken, dog, and so on. Tiger, okay. Next one, display objects. So let's say public static void display objects, and then object, and then objects. There should be void, okay, no return type. Again, okay, display objects, we are sending parameter for list, okay. Okay, I am making mistake, okay, here list, then there should be a array list. List to size, it means something long, plus plus. Again, that's supposed to be array list, okay? That's why we couldn't use size methods, belongs to array list. List get I, that's going to get the object on the ice index using instance of animal. If the object is instance or object of animal class, then we will process as an animal. Get I. This one will return an animal object type. So we should be able to say open here and here, then dot, and then method belongs to that. Okay, animal we have sounds. Let me explain. Here list.getI, this will returns objects. Actually it's animal object, so I will say animal. Typecasting has to be done. There should be animal objects. We do the same thing for fruits. Here let me just say example cat dot sounds methods. Okay, so animal list dot get I will return cat, and then we are going to say dot sounds. Next one is almost identical. Here, instead of reporting to animal, we will report to eatable. So any objects implement eatable interface, we should be able to call for how to eat methods. So first one has apple, cat, and chicken, and then dog, and then dog, orange, and tiger. Okay, seems okay. Again, it doesn't have anything to do with eatable. So let me check. I'm missing something here. Let me check with chicken. Again, here, there you go. We extend animal, forgot to implement eatable interface. So eatable. Then if that's the case, we should implement. We are going to eat chicken. Maybe barbecue. Same thing here, implements eatable. Then you need to implement abstract methods. Belongs to eatable interface. Okay, same way to cook. So this time when you run it, you look at the chicken, now you have a sounds, also how to cook. Also ducks, we have a sounds and how to cook. So, I mean how to eat. All of them shows up, okay? So that's the idea of using interface. Clearly it has an advantage when you're dealing with multiple objects. You like to uh, control the common behavior for those objects. So you can use interface. Another reason is even though you like to share common features of a class, you are not allowed to have two superclasses. So you can pick one as a superclass which has a strong relationship. Everything else you can turn to be interfaces so that you can actually implement it. You can do the exactly same thing. So here what I'm trying to do is we can use a polymorphism. We can say fruits orange equal to new orange. For all those animals, we can do the same thing. Cat is a pet, is a superclass. Dog also same. Chicken, we can say animal. Supertype refers to subtype, okay? Everything is same. Let me make a comment here. Fruit or actually I have to say or and animal. better capitalize it. Here is this object in this list, animal or animal object. Same thing, okay? And then next one we can say, is this object in this list eatable, or implement eatable interface? So the first instance of, we are looking at the inheritance. Second one, we are looking at whether it's implement interface or not. I think that's all. Thank you.